Dear students, in today's class, we are going to learn an important concept which is in the form of a graph. So, whenever we draw a graph, we are going to select two axes. So, the axis, one of the axes is x, the other is y, or it can be even x and one more axis z axis, or you can even draw the graph between y and the z axis. But the commonly selected axes are x and y whenever there are two variables. And we are going to learn a graph, and that graph is called VT graph. VT graph. V stands for velocity, T stands for time. So, what is a VT graph? A graph obtained by plotting velocity along the y-axis and time along the x-axis is called as VT graph. Repeatedly asked question. So, what is the VT graph? A graph obtained by plotting velocity along the y-axis. Whatever the first quantity which is there or that comes, that should be taken along always the y-axis, not along the x-axis. So, if I write acceleration time graph, means I have to take the acceleration along the y-axis and the time along the x-axis. If it is a force displacement graph, then force along the y-axis and the displacement along the x-axis. So, the first quantity is always taken along the y-axis. So, what is VT graph? Graph obtained by plotting velocity along the y-axis and the time along the x-axis is called as a VT graph. Depending on the nature of motion of the body, we get different shapes of the graph. Now, what do you mean by nature of motion? Nature of motion includes whether the body is at rest or in motion, correct. If it is in motion, then whether it is a uniform velocity or not. Again, under uniform velocity, there are two. One, uniform positive again velocity or positive uniform velocity, other is negative. This is the second. Then we have a uniform acceleration. Then we have uniform retardation. Then we have variable acceleration. Variable acceleration. So, all these we can learn by looking at the graph. So, let us see which are the various shapes of the graph that we come across. So, altogether there are 5 graphs. Let us analyze one by one. Look at the graph number 1, first graph, VT graph. In this case, you can see as the time increases, velocity is the same, correct? There is no change in the velocity. So, the graph 1, first graph, is for a body having or moving with uniform velocity. So, that is the nature of the graph. So, if a body has uniform velocity, the shape of the VT graph is a straight line parallel to the time axis. Second one, if you see when t is 0, v is also 0. So, the body starts from rest. After that, the velocity you can see continuously changing, it is increasing. And since it is a straight line, it changes uniformly. So, therefore, the nature of motion of the body is a uniform acceleration. So, therefore, the body starts from rest and moves with uniform acceleration. Next, the difference between this graph and this graph, this is also a straight line, this is also a straight line, but here this starts from origin. This doesn't start from origin. That means here initial velocity not 0, but the body has uniform acceleration. So the difference between this is, here the body has 0 initial velocity, that means the body starts from rest, but in the next graph the body, it doesn't start from rest, it has certain initial velocity and then moves with the uniform acceleration. In the graph 4, fourth graph, you can see the velocity is decreasing, velocity decreases. When the velocity decreases, so what do we call? The acceleration. When the velocity decreases, acceleration becomes negative, and such acceleration is called retardation. So it's a uniform retardation, okay, which is negative acceleration. And the fifth one is, you can see the graph is it's a random graph, there is no particular shape for it. So it is variable acceleration. So these are the different shapes of the graph that we come across, and I'm going to give a graph here. So this is the VT graph, VT graph, and I'm going to draw the graph like this. So now if you look at this graph, the body starts from rest. So this portion of the graph is similar to the second graph. So body starts from rest and then it has uniform acceleration. Now this graph is similar to the first one. That is, then body moves with uniform velocity. This graph is similar to the fourth graph. That is, the body has uniform retardation. So therefore, by looking at the graph, we can very easily understand the nature of motion of the body. What do you mean by nature of motion? Whether the body is at rest, whether it moves with uniform velocity, whether it has uniform retardation, uniform acceleration, variable acceleration. All that we can understand just by looking at the graph. And that is what one of the application of the VT graph. So hope you understood the various shapes of the graph that we come across. So a question that has appeared, you can see in the exam 4 times. What is velocity time graph? So what is the answer for that? The graph obtained by plotting velocity along the y-axis and time along the x-axis is called as VT graph. And what are the various shapes of the graph? The first one indicates uniform velocity. The second one, the body starts from rest and then moves with uniform acceleration. Third graph, body has some initial velocity and then moves with uniform acceleration. Fourth graph, velocity decreases, so that's why it's a uniform retardation. And the last one, variable acceleration. So what are the uses of the VT graph? One of the uses, just now I had mentioned it, that is to find the nature of motion of a body. We can find the nature of motion just by looking at the graph, correct? I had already given the example, I'll give once again. Imagine if this is the graph. Isn't it easy to find the nature of motion of the body? The velocity decreases, and since it is a straight line, it's uniform retardation. Variable acceleration. Uniform velocity. So that is what the first use of the VT graph. The second one, to determine the velocity of a body at any instant. So imagine we know the graph already, VT. I know this value, let it be 10 after 1 second. I know this value, let it be 20 after 2 seconds. Let this be 30 after 3 seconds. I know the velocity is 10 meter per second at 1 second, 20 meter per second at 2 seconds, 30 meter per second at 3 seconds. I know these values. So now I can find the value here also in between. At 1.5 second, what is the velocity? So that velocity has to be exactly midway between 10 and 20. How much it is that? So that's 15. So this is the second application. So based on the graph, I can find the velocity of a body at any instant. Or in simple, we can find the instantaneous velocity. The third one, to find the displacement of the body in a given time. So I'm going to take a graph, VT graph, and this is the shape of the graph. So identify what is the nature of motion of the body. The nature of motion of the body is a uniform velocity, correct? So this is the VT graph. I will find the area of the VT graph or area below the VT graph. Area below the VT graph is nothing but the area of the rectangle. How do you find the area of a rectangle? Length into breadth. Length is this. This is the breadth. So length is a time into the breadth is nothing but velocity. Correct? So area of the VT graph gives velocity into time. But we know that velocity is equal to displacement by time. So from this, what is the displacement? So displacement is equal to velocity into time. That means, so this velocity into time is nothing but is equal to the displacement. So therefore, one of the important point, how to find the displacement using VT graph? By finding the area of the VT graph, or area below the VT graph gives the displacement. Remember, this statement is valid not only for this graph, it's valid even for this also. For example, if I get a graph like this, body moving with uniform acceleration. Now find the area, but this time you have to find the area of the triangle, and that will give you the displacement. What if the graph is something like this? Now what is the structure? The structure is a trapezium. All this we have learnt in our introduction topic, bridge course, area of the various structures. So that is the reason why that bridge course was done, so that you can use all those formulas in the various topic. So now area of the trapezium, area below the VT graph or area of the trapezium will give you the displacement. So therefore, the third application, to find the displacement of the body in a given time. So how to find the displacement using the VT graph? By finding the area below the VT graph. So the fourth one and the last one, if I consider a graph, VT graph. So this is the graph that I am going to consider. I want to find the acceleration of the body. To find the displacement, I can find the area below the graph. How to find the acceleration? To find the acceleration, I have to find, so acceleration can be found by finding the slope of the VT graph. Slope. So the slope is this. So this is the slope. So to find that slope, I have to find this value. So this is change in velocity, this is the change in velocity, correct? I will write it as a dv. That will be along the y-axis, correct? dy. This is the change in the time, dt, which is equal to dx. So dy by dx will give you the slope. Dy by dx will give you the slope. Change in y-axis to the corresponding change in x-axis. But what is the dy here? Dy is nothing but dv. What is the dx here? Dx is nothing but dt. And we have already used this formula. Do you remember? dv by dt. Change in velocity to the time gives what? Acceleration. Acceleration is rate of change of velocity. So this is the fourth application of the VT graph. So what are the four applications? To find the nature of motion of a body, to determine the velocity of a body at any instant, and the third one, to find the displacement of the body in a given time. How do you find the displacement? By finding the area below the VT graph. And to find the acceleration of the body. How to find the acceleration? By finding the slope of the VT graph. So do remember this, because we will be using this in our next important question. So that's application of the VT graph. Okay. Right. So this question, again, it has appeared repeatedly, and you have learnt all this. It's called equations of motion using VT graph. Okay. So first we have to derive an equation. V is equal to u plus ATA. So first let me explain what are these terms. You already know these terms. So V stands for final velocity, U stands for initial velocity, A stands for uniform acceleration, and T is the time. We have to derive this. How to derive? Using a VT graph. So let me take a VT graph here. So this is the VT graph. AB is the VT graph. Okay. If AB is the VT graph, then what is the nature of motion of the body? This is the VT graph. Nature of motion of the body is uniform acceleration with some initial velocity. Initial velocity is not zero. Therefore, in the diagram, this OA represent U, stands for initial velocity. Can you see that? OA and CD, they are equal, right? OA and CD are equal. So this is the U, initial velocity. After a time t, that is a OC, this is a t. This is also equal to t because they are equal, sides are equal. After a time t, this velocity changes to v. So BC is equal to v. So what is OA? OA is the initial velocity. OA is the initial velocity, correct? What is the BC? V, final velocity. If OA is a U, if BC is a V, then we can find this now very easily. What is a BD is equal to? So BD is nothing but this BD is equal to BC minus CD. BC minus CD, correct? Check this, see. BD is equal to BC minus CD. So what is a BC? BC is nothing but V, final velocity, minus what is CD? CD is nothing but OA only, which is initial velocity. Clear? So this graph has to be drawn very clearly, properly, before you start deriving it. Okay? Right. So let us derive. I want to find the relation between final velocity, initial velocity, acceleration, and the time. For that, I am going to consider the first point. The first point is this. How to find acceleration in VT graph. I had mentioned it. To find the displacement, find the area below the VT graph, and to find the acceleration, you have to find the slope of VT graph. Correct? What is the slope? The slope is, I have told you, right, the ratio of change in y axis, which is a BD, correct, divided by the corresponding change in the x axis, which is AD. But we know the value of BD here already. What is that? That's equal to V minus U. V minus U divided by, what is AD? AD is nothing but T. So we have found one important relation. Acceleration is equal to change in velocity by time. We know this already. And now let's simplify. Just multiply here. We'll get AT. AT is equal to V minus U. V minus U. Take this to the other side. You get U plus AT is equal to V. So therefore, V is equal to U plus AT is the final equation. Sometimes they will give like this, or V is equal to V naught plus AT. Where instead of U, they will use the symbol V naught. V naught stands for initial velocity only. Therefore, even if they ask question like this, you derive the same. Understood this? So this is a important is a derivation using the VT graph. We have proved V is equal to U plus AT. Let us derive one more equation, that is S is equal to UT plus half AT square. To derive this, I will find S. S stands for the displacement, correct? So how do you find the displacement? Displacement is equal to the area, correct? Area below the VT graph. What is the shape of the VT graph? The shape here is a trapezium. So it's an area of trapezium, which is half into base into sum of parallel sides, correct? Displacement symbol is S, half into. What is the base in this trapezium? So this is the trapezium. These are parallel side. This is one parallel side. This is the other parallel side. So height is this. OC is the base or the height into sum of the parallel sides. One is OA plus the other is BC plus BC. So that is half into, what is OC? So OC here is nothing but T into OA plus BC. What is OA? That is U plus, what is the BC here? BC is nothing but V. So that's half T U plus, replace V from here. What is the V? V is equal to U plus AT. U plus AT. So that's half T into U plus U is nothing but 2U plus AT. Correct? Now open the bracket. When you multiply, when you open the bracket, this 2 into 2 will get cancelled. You will get U into T. U into T plus half T has to be multiplied here. So half A T into T is nothing but T square. See how easily we have found the other equation, which is S is equal to UT plus half AT square, using the same graph. So for every derivation you have to draw the graph and you have to write all the proper statement where you use the initial velocity, V is the final velocity. Okay. So what is this equation? This equation will give you displacement of the body in a given time. The first equation will give you velocity of a body in a given time. Velocity at a given time is given by V is equal to U plus AT. Initial velocity, uniform acceleration, time. Displacement, initial velocity, time, constant, uniform acceleration, time. Clear? There is one more equation which is v square is equal to u square plus 2as. Okay, before that, the other alternative equation which they give for this, instead of s, they may give you x v naught t plus half a t square, alternative. Okay. So, even if this equation is given, the derivation remains the same, only variables are different. So, let us complete the third equation, which is v square is equal to u square plus 2as. To derive this, these steps are the same. Till here it is the same. I will write this till here. S is equal to half t into u plus v, into u plus v. So, what we did here, we replaced the v and then we got the equation. But now, for the third equation, instead of replacing v, we replace a t from here. What is a t? Rearrange. T is equal to v minus u by a. So, that is what we do. Half t is nothing but v minus u by a, v minus u by a into u plus v. That is half. What is v plus u? V minus u. It is a plus b into a minus b formula. That is a square minus b square. So, therefore, here v plus u into v minus u is nothing but v square minus u square by a. This is. So, now multiply here 2as is equal to v square minus u square. Bring u square to the left. U square plus 2as is equal to v square. Therefore, v square is equal to u square plus 2as. So, you can see with the help of this equation, we have derived the second, correct, and with the help of this equation, we have derived the third, and while deriving, the steps still here is the same, correct. If you replace a v as u plus at, you will end up with the s is equal to ut plus half at square, and instead of v, if you replace a t, then you will get v square is equal to u square plus 2as. An alternative to this is v square is equal to v naught square plus 2ax. That is the alternative equation which they may ask. Okay. So, hope you will have understood the three derivations, because all the three derivations are important from the exam point of view. So, you can see the question that has appeared in the exam. Derive s is equal to ut plus half at square using VT graph. Question has appeared almost 5 times, including this year. It has appeared in the district level exam. The next question is derive v square is equal to u square plus 2as using VT graph. Again, the question has appeared. These are all 5 marks question. 5 marks derivations are there, no? So, under that they will ask this. So, what is the VT graph? And using VT graph, derive, so this is a commonly asked questions. Okay. So, practice these derivations, because as I have told you, so there will be a test soon once we complete this particular chapter. So, I am going to continue the rest of the topic, and based on these equations we are going to solve some numericals. So, till then, take care.